Hello, fellow programmers. Today, we are going to dive into a topic that makes working with databases in Java a whole lot easier. We are talking about Spring Data JPA. Imagine you are building an application, maybe a simple address book, or a list of your favorite movies. You need a way to save this information so you can access it later. That is where a database comes in. Getting your Java application to talk to that database can sometimes feel like a complicated chore. You have to write a lot of code just to save. You have to write a lot of code just to find. You have to write a lot of code just to delete a single piece of information. This is where Spring Data JPA steps in to save the day, acting as a friendly translator between your Java code and the database. Think of it as a powerful tool within the larger Spring framework. Its main job is to simplify the process of data persistence. That means it makes saving data straightforward, and it makes retrieving data straightforward. Instead of manually writing code to handle connections, execute queries, and map results back to your Java objects, Spring Data JPA does most of that heavy lifting for you. It provides a higher level, more abstract way to interact with your data layer. This lets you focus on your application logic, not database plumbing. In the old days, developers used JDBC, Java Database Connectivity. JDBC is powerful, but very verbose. Even simple tasks, like finding a user by ID, took many lines. Spring Data JPA follows convention over configuration. To understand the magic, we need a few core concepts. The first and most fundamental one is the entity. An entity is a POJO that is mapped to a table in your database. Think about a student class in a school management application. This class would have properties like ID, first name, and last name. Add entity above the class to tell JPA to persist objects to the student table. Each field corresponds to a table column. We use annotations to make mappings explicit. Mark the ID field with ID for the primary key. The primary key uniquely identifies each row. Other fields like first name and last name map to columns by name. This direct mapping is the cornerstone of JPA. You work with Java objects. JPA handles rows and columns. Next up is the repository. Entity is the what. Repository is the how for saving, finding, and deleting. A repository is an interface in your code. You do not write the implementation. Spring Data JPA creates it for you at runtime. Just extend JPA repository, and you get a full toolbox of methods. You are telling Spring which entity and primary key type you use. Instantly get save, find by ID, find all, and delete by ID, with no SQL. It is like a skilled assistant writing your data access code. Now that we have our entity and repository, let us perform common database tasks. CRUD. These are the fundamentals for any application. Spring Data JPA makes them intuitive. To create, instantiate a student object. Set its properties, like first name and last name, then call save on your repository. Spring generates the SQL insert and executes it. No manual SQL or connection handling. If the object has an existing ID, save performs an update. It generates a SQL update for you. To read a single record by ID, use find by ID. To read all records, call find all to get a list. For deletes, delete by ID removes a record by its ID, or pass the entity to delete. These clear method names keep your code consistent and simple. Getting started is simple with the Spring initializer. Choose Maven or Gradle, pick a Spring Boot version, set group, and artifact. Add Spring Data JPA and a JDBC driver like H2, PostgreSQL, or MySQL. Generate, unzip, and open in your IDE. Configure your database in application.properties or application.iml. Set the URL, username, and password. For H2 in memory, configuration is minimal. Add spring.jpa hibernate.ddl auto update for schema auto creation. Create your student entity with a entity, AID, and fields. Create student repository extending JPA repository. Auto-wire the repository into a service or controller. Use save, find by ID, and find all to interact with the DB. Run the app and watch objects persist and retrieve seamlessly. The primary benefit is massive boilerplate reduction. With JDBC, you manage connections, built SQL strings, executed queries, iterated results, mapped columns, and handled exceptions. Spring provides a repository abstraction, and handles the implementation for you. Complex operations become single-line calls. This boosts productivity and speeds up development. Declare methods like find by last name, and Spring generates the SQL. For example, select from student where last name posture. The framework reduces SQL injection risks and resource leaks by default. Names like find top 10 by order by registration date to SC are self-documenting. It is a smart layer that abstracts persistence complexity. For modern, efficient, maintainable apps, it is essential.